Hello students, so in this video I'm going to continue with exercise 1C question number 5. In all the previous videos we have done up to question number 4, explain all the theories and explain the procedure of solving the sums. So in this video I'm going to explain you question number 5 from exercise 1C. The question, let us read first. The question says, find HCF and LCM of the following pairs of integers. Means what? They've given you pairs of integers, positive integers. You have to find the HCF LCM. That means it's almost same like question number 4. In question number 4 also you have found the HCF and LCM of these given pairs of integers by applying fundamental theorem of arithmetic. But in this question number 5 they are saying what? Find the HCF and LCM of the following pairs of integers by prime factorization method. So 4 and 5, if you look just like this, they look different, but ultimately they are almost same. Why? Because in fundamental method also what we do, these given integers we express them as the product of prime, and prime factorization also is same only. Prime factorization means expressing a given number in the product of prime, okay, as the product of primes. So basically they are same. So the first part is same like 4. So if you have learned nicely this number 4, you have understood, then number 5 will not be much difficult, okay. It's almost same, okay, similar. But here in this question we have one more part. Find the HCF and LCM of the following pairs of integers by prime factorization method, and this is the second part, and verify that. You have to verify, you have to check, verify that LCM into HCF is equal to the product of the two numbers. That means you have to verify that the product of HCF and LCM of these two numbers is equal to the product of these two numbers themselves. So it means two parts in this question. The first part is find the HCF and LCM, find the HCF and LCM, and the second part is what? Verify this equation, okay, or this identity, okay, or you can say this rule. Now first of all let me explain you something about this rule, okay, the second part, because finding HCF and LCM is not much difficult because we have done in question number 4. But before I do the sum, show you how to solve, let me first explain something about the second part, okay. So here's something about the second part. Please see carefully, students. So this you have to try to understand and remember. I've explained this in the last video also when I was explaining about application of fundamental theorem of arithmetic to find HCF and LCM for question number 4. So here you can clearly see that here the topic is what? Relationship between HCF and LCM. That means what? There is a clear relationship between the highest common factor and the lowest common multiple of any two numbers, okay. Now this rule, whatever I'm going to give you here, is meant strictly for only two positive integers. Means this rule is not applicable for more than two positive integers. It is applicable only for just two positive integers. So let's read this. For any two positive integers a and b, that means what? If I give you any two positive integers, means natural number, if I give you any two natural numbers or positive integers a and b, then the rule says that the product of HCF of those two positive integers a and b and the LCM of those two positive integers, the product of HCF and LCM of those two positive given integers a and b, this product, this multiplication is always equal to the product of those two given integers, positive integers. That means what? If a and b are integers, their product will be always equal to the product of their HCF and LCM. That means a very clear relationship here is what I'm trying to say is that I give you two numbers, you find their HCF and LCM. Now you find that in one side you multiply their HCF and LCM. That's the two answers, HCF and LCM, you multiply on one side, and the other side like here, you multiply those given numbers, those numbers whose HCF and LCM you have found. Then you find that if your answer is correct, if everything is okay, then this product will be always equal. The product of two numbers is always equal to the product of the HCF and LCM of those two numbers, okay. So there's a rule, there's a relationship. Now from this relationship we have these four results. Please try to understand, because these four results are going to be applied in other sums, okay, to come, okay, in the same exercise. So the first result is this one. Look, from this relationship, you can see that HCF and LCM are on the same side, left hand side, and A and B are on the right hand side. So what I can do is that if I keep HCF on the same place, that is left hand side, and this product is on the same side, that is right hand side, and if I carry this LCM to the other side, or if I transfer this LCM to the from the left to right side, so LCM is on this equal is the boundary. This is left hand side, this is right hand side. So if this LCM is now on left hand side, so if I carry it to right hand side, then this divide will become what, whenever we transfer any quantity from one side to other side, left to right or right to right, then the operation changes, sign of operation change. That is, plus becomes minus, minus becomes plus, means addition becomes subtraction, subtraction becomes addition, multiplication becomes division, and division becomes multiplication. Okay, when you transpose or transfer. Okay, so here, since LCM is multiply, here product, then this when I take to other side, it will come divide. So that's why LCM when I take to other side, it will come divide by, so means it will come down. That's why HCF is equal to A into B, this LCM into, if I take this side, become divide. Okay, so in this way this rule is okay. Now same thing for LCM also. Then if you keep LCM on the same side and take HCF this time, suppose you have decided to take HCF this side, then HCF, which is multiply here with LCM, this HCF will also become divide. Okay, A and B remains same because A and B is on the right hand side. We are not changing this one, only HCF or LCM we're taking. So LCM will be equal to A into B divided by HCF. The HCF will go down. Okay, so this means what? There's a very useful formula to find HCF and LCM in a particular question. Okay, suppose I give you a question where I've given you two integers and I've given you either the LCM is given or HCF is given, and then I'm telling you find the other. Then suppose I'm giving you LCM and A and B, then find HCF, then there's a formula. But if I give you A and B and HCF, then I'm saying find LCM, then there's a formula. Okay, a very useful formula. Okay, keep in mind. Okay, HCF is equal to what? Product of those two integers divided by their LCM, and LCM equal to what? Product of those two integers divided by their HCF. Okay, in this we can find LCM. Okay, now look at this 3 and 4. Sometimes in some question what they do is that in some problems they give you the values of HCF and LCM of two numbers, and out of two numbers or two positive integers, one of these will be given to you. Either A will be given to you or B will be given to you, and the other one will not be given. In such a case, there is a formula. If I give you A, look, suppose I give you integer B and HCF and LCM, then I have to say I'm telling you find A, and there's a formula. See, since I have to find A, the A is unknown, so suppose that HCF, LCM and B are known and only A is unknown, so we keep A here, we take B that side. So HCF into LCM same, HCF into LCM same that side, and then into B, multiply B, take the side, become what? Divide B. So this is the value of A. A is equal to what? Product of HCF and LCM of two numbers divided by one of the numbers. Okay, clear? This is B. And same you can find B also like that. If you have to find B, then divide by A. If you have to find A, divide by B. But HCF and LCM will remain up numerator. Okay, so I've explained this formula result. Now let us do one sum. Okay, from question number 5. So students, this question number 5. I've already read the question, so let us do question number 1. Remember what you have to do? You have to find the HCF and LCM of these two numbers, positive integers, and also you have to verify this rule that HCF into LCM is equal to product of the two numbers. Okay, you have to verify that it's true. Okay, it should be true because these are like some rules, okay, which have been verified with some proofs. Okay, so proofs not given to you, I have not shown, but then you have to take them as true. Okay, that's correct. Okay, so we have to verify that that's true. Okay, that's correct. So or it satisfies the formula. Okay, this rule. So let's start. So first I'll start with question number 1. So first of all, find HCF and LCM of these two numbers by prime factorization method. So let us now do the prime factorization method of 26 and 91 separately. So same rule for prime factorization. What do we do? We divide by the prime numbers. So these are the prime numbers, I told it by heart. So since the first one number is 2, so let's divide by 2. 26, can you divide by 2? Yes, because 26 is even number. Remember, even number, unit digit 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. Even number. Since the 6, even number, we can divide by 2. 2 ones are 2. 2 ones are 2. 2 minus 2, 0. No carry. There's only 6. And 2 3s are 6. Okay. That means we have been able to divide by 2. Now it's coming 13. Now the question comes, by which table you can divide, no? By which prime factor? But we all know, if you remember, but we all know that 13 is a prime number. These are prime numbers, okay? The 13 is a prime number. And I told you that the moment you see prime number, do not waste any time in solving, okay? Finding out which number. Because prime number is divisible by itself. So 13 ones are 13, okay? So finish prime factorization of 26. Now we'll do prime factorization of 91. So same thing. First we'll try to divide this 91 by 2. But can you divide 91 by 2? Then check whether it's even or odd. 1. 13579. 13579 when you have in the unit digit, it is odd number. Since it's 1, this is odd number. Odd number we can never divide by 2. So since we cannot divide by 2, now let's try by 3. Can you divide 91 by 3? Then I told you that to divide any big number by 3, one rule is what? The test of divisibility. It says that you add the digits. You add the digits. If the total is a multiple of 3, then you can divide by 3. So let's add 9 plus 1, 10. Now quickly recall table of 3. Does 10 come in the table of 3? 9 plus 1, 10. So keep 10 in mind. 10 in mind, 10. Now recall table of 3. 3 1 is 3, 3 2 is 6, 3 is 9, 3 4 is 12. 10 doesn't come in the table of 3. That means this is not divisible by prime number 3. Okay, so 3 is not a prime factor of this 91. Then we move on to 5. Next prime number is 5. But you know, for 5, I already explained you that for any positive integer to be divided by 5, divisible by 5, the unit digit should be 0 or 5. But see, there's neither 0, there's not 1 or 5, there's 1. So we cannot divide by prime number 5. Okay. Now after 5, confirm that it's not divisible. Now we should try by 7. For 7, there's no test. You have to divide in the rough. So let's divide 91 by. Let us divide 91 by 7, because as I said, for the prime number 7, there's no test. So divide 7 ones are 7. 21, then 7 3. So 21, see, remainder 0. Yes, divisible. So yes, we can divide by 7. Okay, 7 on the 7 and 7 3s are 21. This means 7 13. So whatever answer comes, we will divide 13. So means we have been able to divide by prime number 7. So 7 is a prime factor. But coming 13, and since 13 we already know, we have done here also that 13 is a prime number. So prime number we divide by, so 13 ones are 13. So we finished the prime factorization here. Okay, so now we'll write. So now we'll write the prime factorization, okay, of both this number. So we got prime factorization of 26 equal to what you got? 2 into 13. And 2 is only one time and 13 also only one time. So write the power, okay, 1 1. Now we'll write prime factorization of 91. 91 is what? 7 into 13. 17 also only one time and 13 also one time. So write in power notation, okay. After that prime factorization, now we'll find HCF. Therefore, HCF of 26, 91. HCF. So in the previous videos in question number 4, I've explained you that HCF is nothing but is the product of only the common prime factor, that also with the lowest power. HCF is the product of all the common prime factor, only common, same. Uncommon will not take, only common prime factor with the lowest power. So you can see here that in this 2 prime factorization of 26 and 91, what is common? 2 is not common, because see, 2 is present in 26 but 2 is not present in 91. 7 is present in 91 but 7 is not present in 26. But 13 is common, so 13 is a common prime factor, so we take 13. 13 is common prime factor, so 13 common with the lower power. In this case, both the powers are 1 1 equal, obviously, and there's no the power less than 1, so 13 power 1. So it is the only common prime factor, that also with lower power, both are having 1 1, so 1. Okay, and 13 raised to power 1 means it's only 13, because 13 power 1 means 13 one time. Okay, 13, finished. So this is the HCF. Okay, now let us find LCM. Therefore, LCM of 26 and 91. As you know, LCM means what? I've explained in the last video. LCM of any two positive integer or any two or more integers, it is the product of all the prime factor, means all the prime number that you have, right? All, and with the highest power, with the largest power. So first of all, tell me which are the prime factors here. 2 is a prime number, 7 is a prime number and 13 is a prime number. These are all prime factors. See, 2 is there, 7 is there, 13. See, 2, 7, 13. These are all prime number. 2, 7, 13. They're all prime factors. Right with the highest power. 2 also has highest power 1 only here. 7 also has highest power 1 and 13 also has highest power 1. Okay. So 2 raised to power means 2 one time. 7 raised to power 1 means 7 one time only. Sorry. And 13 raised to power means 13 also one time. Okay. So now multiply. 2 into 7, 14. 14 and 14 into 13. 4 into 12, 3, 4, 1, 4, 1, 2. That means we have got the answer. That means HCF and LCM we have found. So means the first part of the answer is finished. First part. Find the HCF and LCM of the following by permutation methods. First part is finished. Okay. HCF and LCM got. But the second part is what? And verify. Verify. Check. Verify that the product of HCF and LCM, the product of LCM and HCF means the product of this and this. Okay. 182 and 13. Okay. Verify that the product of HCF and LCM is what? Is equal to the product of the two numbers. Is equal to product of these two given numbers. Okay. So since we're going to verify here, so the process of verifying is called verification. Okay. So let us write here heading verification always. Okay. Verification. So here I'm going to verify. So right here verification. Okay. Clear? So now we'll do here verification. So for verification, what you do is that you just copy this rule, this whole statement. Okay. Verify what? Verify what you have to verify. Verify that what? So write this everything. So verify what? You have to verify that. It's given here in the question. LCM into HCF should be equal to what? Should be equal to the product of the two numbers. Product of the two numbers. So let us verify. So we give here this implies. See, this implies because equal is already here. This implies. This means. Now just put all the values here. What LCM you got? What is the LCM you got? Answer 182 into HCF. And see what HCF you got? 13. So you can see here the HCF of this number is 13. So the product of LCM and HCF should be equal to what? The product of the two numbers. And so which are the two numbers here? The two given numbers are here in this first question is what? 26 and 91. These are the given numbers. Product of the two given numbers. So 26 into 91. So we multiply this two and put the values. Okay. And if you get the answer equal means we have verified. Okay. It's true. Clear? So let me multiply this. So students, here I multiply 182 and 13. Okay. Which gives us 2366. Okay. The product of LCM and HCF. Okay. The product of these two giving 2366. And here's the product of the given number. So this is 26 and 91. And when I multiply, see, I got here also 2366. So that means we got equal answer. Okay. Same answer. You must get same. Okay. You must get same. If you don't get equal, if you don't get same values, if you don't get the same values, it means that some mistake you have done while multiplying, or there's some mistake in finding the HCF and LCM. Okay. If your product is correct but you're not getting equal, it means maybe HCF and LCM has some problem. Okay. To find. Okay. Maybe it's not correct. Okay. So if everything is okay, these two products must come equal. Okay. Must come equal. Okay. So let's put the value here. So the product of HCF and LCM, what we got? We got 2366. 2366. And the product of the two given numbers is also 2366. So since we got equal same, so finally conclude that therefore left hand side, here left hand side means the product of HCF and LCM is equal to the right hand side, and here right hand side means the product of the two given numbers. So yes, we have proved that the product of HCF and LCM of any two given positive integers is always equal to the product of the two given numbers. Okay, or two given positive integers. Okay, they are always equal. Okay, so once you get equal means what? We have verified. So finally conclude like this, hence verified. So therefore we have verified our results. Okay, that means our results are correct. So understood all of you students? So I hope all of you have understood. So first what we have done, first we have found the prime factorization, and then we have found HCF LCM. In the second part we have done verification, okay, which has come out to be equal. So same way you can try other questions, okay, from this exercise, okay, from this particular question number 5, okay, the other two. So you practice this nicely, copy this nicely, and try to understand and practice other sums, okay, do other sums. Thank you.